All right, y'all. So now we're going to put this whole process together for means in this 4-step process. So notice here, the inference method is now called a one sample t interval for mu, right? That's our inference method. So that'll be in the plan part, right? You'll put that. Again, state, plan, do, conclude. Same type of process here. Again, make sure in that plan part, right? Again, plan seems to be the most important part right now. The whole idea of the normal large sample condition, right? So be aware that in that, you have to make sure to include the graph of the sample data when the sample is small and you don't know about the population shape. Now, having said this, I am Mr. Nice Guy, right? You are just intro to stats. So I actually have the data dot plot put out there for you. So the problem only included the data. I made the dot plot. I gave you the summary statistics of the sample data so that you could then do the problem without that extra step. So you are very welcome. All right. I heard it. Okay, here we go. So it says, can you spare a square? Christina and Rachel randomly select 18 rolls of a generic brand of toilet paper to measure how well this brand could absorb water. To do this, they poured 1/4 cup of water onto a hard surface and counted how many squares of toilet paper it took to completely absorb the water. Here are the results from their 18 rolls. Construct and interpret a 99% confidence interval for mu equals the true mean number of squares of generic toilet paper needed to absorb 1/4 cup of water. So as you can see, I love you a lot more than I loved my people last year because I had to add that because last year I made them do it themselves. Man, how mean am I? But again, it's COVID time. I have a little compassion. All right, so there's the dot plot. There's the summary statistics. We need to construct and interpret a 99% confidence interval for mu equals the true mean number of squares of generic toilet paper needed to absorb 1/4 cup of water. All right, so we're going to start, just like we started the other 4-step process, with the state. And again, what's nice about your Edulastic is that you should be able to copy and paste, or hopefully you can, from the given problem. So we're going to state we want to estimate mu equals, and again, I'm just gonna write this down, right? The true, and if you just think if you had to write it by hand, typing I think is a lot faster. The true mean number of squares of generic toilet paper needed to absorb 1/4 cup of water. And then remember, in the state, you have to state the confidence level at a 99% confidence level. Okay, so there's the state portion. Okay, all right, so I'm going to erase that, and now we're going to do the plan part. So again, this is where sort of there's a lot to think about. So first of all, our inference method is a one sample t interval. Remember, we have to use that table A to find our t value. So that's a t, not a, I don't know what that is, a t value. There you go, t interval for mu. Random condition. So randomly selected 18 rolls of generic brand of toilet paper. Randomly selected 18 rolls of a generic brand of toilet paper. So it passes the random condition. And now we need to do the normal large sample condition. So again, in the problem, first I would look for normal, right? I don't see the word normal. Then I would look at the sample size. The sample size is only 18. So then I have to graph the data. And again, I did it for you. And you can notice that there's no outliers. The middle has the most. So this is, very much or close to symmetric, or at least it's not strongly skewed. So we're going to say that the dot plot of the sample data shows no strong skewness or outliers. And because of that, that's a check mark. our conditions are met, and we may go through and do the calculations. Okay. All right, so now we're going to do the calculation. So again, in the end, we want to create our confidence interval. That formula is x bar plus or minus t star times the sample standard deviation over the square root of n. So we know almost all of these just from here, right? This tells us that n is 18, x bar is 24. 0.944, and that'd be squares. And then the standard deviation, Sx, is 2.859 squares of toilet paper. So now we need to find that t star. So remember, to find t star, you have to identify your confidence level, which is 99, and your degrees of freedom, which is your sample size minus 1. So my degrees of freedom is 17. So 99% and 17. So here I go. Table B is right here. Let me zoom in. There we go. 99%, 17. If I come up here, I can use, I'm sorry. 99%, 17. Go over, go up. And there is my t star value, 2.898. Beautiful. 2.898. All right. Sorry if I've not been presenting the entire time. So my z star is 2.898. And now I can fill out my confidence interval formula. So my x bar, my point estimate is 24.944 plus or minus my z star, t star, not z, t star. Hope that's a t. Hope it's not a z. T star of 2.898 times my sample standard deviation of 2.859 over the square root of my sample size, n. Remember, I bring down the point estimate, I bring down the plus or minus, and I type, I'll do it in red, I type the margin of error into the calculator. So I'll do that with you here. Let me take a picture because those decimals are hard for me to remember. There we go. Okay. So we're going to go away from this to the graphing calculator. So 2.898 times this fraction of 2.859 over the square root of 18. And there's my margin of error. I'll go 3 decimals because that's what my measurement is. So right now I have 24.994 plus or minus 1.953. Right, that 2 gets rounded up to 3 by the 8. And now I'm going to take those numbers and I'm going to subtract and add them. 24.99, or 9, I'm sorry, 944. Sorry. 24.944. 24.944. So I'm going to take that 24.944 minus 1.953 and 24.944 plus 1.953. And there is going to be my confidence interval. So my confidence interval is between 22.991 to 26.897, and that'd be squares of toilet paper squares. That's the confidence interval I was looking for. And now we have to conclude. So I'm going to go back to my notes here to write the conclusion, if you don't mind. Okay, so let's make our conclusion. So when we conclude, again, we are just interpreting the confidence interval. So to conclude, I'll do it in blue here. We are 99% confident that the interval from, and it was 22.991 to 26.897. I'm not going to put the units because I'm going to talk about that next. Captures the true. And now again, this is where I just restate this. The true mean number of squares of generic toilet paper needed to absorb 1/4 cup of water. And again, hopefully you can copy and paste. Just copy and paste that from the state part, and you're good to go. Okay? Awesome. Great. So hopefully this makes this section go a little smoother. It builds on section 7.5, and you're good to go with the homework. All right. Thanks for watching. Ask questions if you have them.